topic called as graph. We had defined the graph at that time as the pair of it's a tuple, two tuple v comma e, where v is set of vertices and e is set of edges. Every edge is the pair of vertices on which it is incident, and then we have used the adjacency matrix technique to accept the graph, to store that information about the adjacency in the vertices, and we had gone for the breadth first search and depth first search of that particular graph, right? It was the use of the queue as well as stack. Now today we will go further, and instead of using adjacency matrix, we will be using adjacency list. And as I have told you last time, it is going to be the application of linked list, where the list will be created in such a way that it is going to be, each node will act as the header of some other list. It is a list of lists. Slightly difficult type of application, we can say. But if you do this program, as I have told in the morning batch also, that you are required to submit the printout on Friday, day after tomorrow. Whatever program we are going to do today, that particular program you will have to type, execute and submit the printout on Friday. Okay? Because this one assignment will contain everything that we have studied up till now, except the expressions. It will contain stacks, queues, linked list, list of lists and graphs, everything. Okay? You have almost 72 hours to complete it, right? 4 days, no? 1.5 hour less, 70 hours. Okay, give me last time's graph. मी असा नव्हता काढला. Yeah. So the last time's graph was V0. Now I know that there are a few students who have shifted from morning to evening batch today. They will be having a different picture than the one I am drawing right now, and hence they will have to either take down this graph or write the lists etc. according to the figure that they have. This was the graph that we had last time. Reflection. Okay. Now today's concept will be, the age list will be given, and that age list will be given by the user as say V0, V1, then say V3, V5, then V3, V6, then it could be V1, V3, then V0, V2, it could be V2, V4, V1, V4, V4, V5, V5, V7, then V6, V4. Have we covered all the ages? V3, V4, 1, 2, 3, 6, 9, 11 ages. That was our problem last time, right? So the age list will be given by the user, and see the procedure, understand the procedure of creating the adjacency list. I will be generating one node. I will be generating one node which will act as the header node for the entire graph, and it will have two pointers, one as a down pointer and one as next pointer. Initially, as only header is generated, both the pointers next as well as down are null. I accept the first edge, which is V0, V1. The sequence of operations will be, you will have to check in the down list whether vertex V0 is present. Of course, vertex V0 is not there, there is no vertex. So I will have to append the down list by a node of the same type. Vertex V0. Okay, and then in its next position I should attach another node which is adjacent to it, that was V1, because the edge was V0, V1. But when V0 is adjacent to V1, V1 is also adjacent to V0. So I will have to repeat the procedure, search for V1 in the down list, it is not there. So append the down list. So append down list by V1 and its next list by vertex V0. So the first edge has been considered fully. Now the second edge, V3, V5, search for V3 in the down list, it is not there. Append down list by vertex V3 and append its next by V5. And then search for V5 in the down list, again it is not there. Append down list by V5 and its next by V3. So the second edge is over. V3, V5 is over. Next edge is V3, V6. Now you are required to search for V3 in the down list. We find V3. Append its next list by V6. And search for V6 in the down list, it is not there. So append down list by vertex V6 and its next by V3. So the third edge is over. Fourth edge is V1, V3. Search for vertex V1. Vertex V1 is already there. Append its next list by V3. Search for V3, append its next list by V1. So V1, V3 is over. Then you have V0, V2. Search for V0, append its next by V2. Search for V2, it is not there. So append down list by vertex V2 and its next by vertex V0. And like that we will just continue. Search for V2, append its next by V4. Search for V4, it's not there. So append down list by vertex V4 and its next by vertex V2. Then V1, V4, search for V1, append its next by V4. Search for V4, append its next by V1. V4, V5, search for V4, append its next by V5. Search for V5, append its next by V4. V5, V7, search for V5, append its next by V7. Search for V7, it is not there. Append its next by V5. V6, V4, search for V6, append its next by V4. Search for V4, append its next by V6. And then V3, V4, search for V3, append its next by V4. And search for V4, append its next by V3. And then you can check the degree. V0 has degree 2. So there will be 2 nodes next to it. V1 has degree 3. V2 has degree 2, V3 has degree 4, and so on. We have a vertex of degree 5, V4. This will be the adjacency list of that particular graph, and it has to be created exactly in the same manner as I have generated it. Now there are two types of nodes. The first node that we will be having is declared as, say, type def struct h node. It will have int types var vertex. It will have struct h node types down pointer, and it will have struct the next node के लिए. It is not h node because these nodes do not have down pointer. नेक्स्ट तो बराबर है, नाम चाहिए ना उसके लिए कुछ. हाँ, सिर्फ नोड नको, ए नोड. And I declare it as star h node, capitals. And then I will also declare struct a node, which will have int var and struct a node types next, and I will declare it as new type a node. So there are two types of nodes. One, they belong to the down list, and other belonging to the next list. So it is going to be list of lists. The header in this case is going to be of h node type. Okay, and it will have only down, it will not have next. Its next will be null. Now the functions which we are discussing in all these cases is, of course, first one will be get head or h node, because you will have to append the down list as well as get node, that is our standard list type of node. Then you are required to search in the down list. You are required to append the down list, and you are required to append the next list. This is how we have already discussed the algorithm. Take a node, take the list, take the edge, two vertices, search for the first vertex in the down list. If found, append its next by the second vertex. Search for the second vertex in the down list. If it is not found, append the down list and then append its next by the first one. This is the entire procedure. So algorithm will also go in the same manner. Search down, two possibilities, node is present, not present. If it is present, append its next by the second vertex. If it is not present, append the down list and then again append next. Ask the user whether there are any more edges. If yes, again repeat. If no, at the end return the header. Okay, so we will be generating the multi-list in this case, called as the adjacency list representation for that graph. So I want you to take down that list and carry out the procedure of generating this, so that we can proceed to write first of all these functions, and then the function read graph, print graph, and then we will proceed to BFS. Okay, there is a, you can observe I have left one line blank over here. So when you take down, you also should leave one line blank. I will explain why afterwards. Don't just copy the figure, I want you to follow the procedure. Any doubt in the procedure? Okay, now the breadth first search that we will be using. In that BFS we have used one more array called as visited, and here also we are required to use such an array. But instead of that, as we are going to use the list for it, I will prefer to assign this type of node as one more value which will indicate whether the list has been visited or not. And for that I had left this space. I will say it is int visit, so that when vertex is visited it will be marked as true, otherwise default it will be false. Okay, now let us proceed to write these functions first. You already have the figure now. The first function will be hnode types get head, where you will declare hnode types n equal to malloc size of struct hnode, n arrow visit equal to 0, n arrow down equal to null, n arrow next equal to null, return n. You can take down these functions because there is hardly anything that I will have to explain. Anode types get node will be again quite similar. It will be anode types n equal to malloc size of struct a node, n arrow next equal to null, return n. Actually I shouldn't have written these functions, you can very well write them. Next function will be search down. It's the same function search that we had written earlier in the linked list. You are required to return the pointer if the node is present, otherwise return null. Search in the down list, you will be supplying the header. कोण बोलते रे? अरे गप्पा नका मारू. चुकून आवाज बिवाज ओळखला तर प्रॉब्लेम होईल. int v, hnode types temp, you will say temp equal to h arrow down while temp is not equal to null. If temp arrow ver is equal to v, return temp. Otherwise go to temp equal to temp arrow down. डाउन लिस्ट मध्ये सर्च है ना. At the end you can return temp. If you reach this return temp, it will return null, indicating that the node is not present. Of course, function can be very well modified and written as while temp and temp arrow VAR not equal to V, temp equal to temp arrow down. So exit will be on two cases, either temp is null or vertex matches. In either case you are going to return temp. So instead of these many lines, it will be hardly 4-line function. Is it okay? Now the next function will be append down. Append the down list by V. I will have to generate a node in this case, and I will have to reach that node whose down is null, because then after that I will be adding the node. So temp is equal to H, and while temp arrow down is not equal to null, temp equal to temp arrow down. So you will obviously reach that node whose down is null. So you will have to attach the node over there. N equal to get head, N arrow VAR is equal to V. So the node has been generated. Attach it as temp arrow down. And difference between the previous append down function and this append down function is that I am going to return N, because my immediate step will be append the down list and then append the next list. So I require that particular header. Okay, in the morning batch I had written it as void type function, and then I had to search for this new node that I have attached. Okay, now I don't have to do that because I am returning that N. So immediately in the next list of this N, I will be attaching the other vertex. So that is what I say, okay, every time I teach DSF, I will be doing something new. So switching over the batches will be slightly problematic. Though the same contents are there, the code will not match. 1 or 2 lines difference will be always there. And that too, it is in the same day the changes are there. Anyway, fine. It was because by mistake I had not written it as void. I had just changed this search to append, which made me think that if I use the return type as H node, then will there be advantage? And yes, in this case there is advantage. In the morning this function was already there, search down, and I had separately written append down, and I said that write it as per the previous one. So it was the previous append function. Now you will have this, and we will write the code accordingly. Any doubt in append down? Append next. I am still sending H node types H. whereas I know that this header is not the header of the linked list. You can modify this to H-node types something like P, just to avoid the confusion, because it need not be called with the actual header. It will be some down list node whose next is to be appended. So I am just changing it to P. Now I will have to check. We will first of all generate the node. Now it will be get node, and n arrow VER will be V. Now the possibility is the node that is passed to me, it doesn't have next. That is what it was happening right at the beginning. When I perform append down, then that node will not have next. So I will have to generate the node and attach it as next of this. So it will all depend as whether P has next. So I will just check if P arrow next is equal to null, then I will have to simply attach the node as next of P. Else, if the list is already there, then I will have to reach the last node. So I will start with saying temp equal to P arrow next, because P arrow next exists, and while temp arrow next is not equal to null, temp equal to temp arrow next. So you will be at the node whose next is null, that is the last node, and you will have to attach the node after it. Temp arrow next is equal to n, would be append next function. You should have a clear understanding here that I am passing H node types P, whereas inside the function I am declaring A node type. Now to read the graph. H node types read graph function. So it will follow the entire procedure that we have just carried out, and will return the header of that multilist. So there will be H node types H, and probably I might require temp. I will start with creating the header, which is H equal to get head. I will also require int IJ, that is the age. Once the header is created, I will ask for the age, that is 2 integer values, vertex numbers, I and j. Now I will say temp equal to search in the down list from that header I. Possibilities are either it is present or temp becomes null. So I will just check if temp is equal to null, then I will have to append down list. I will say temp equal to append down H comma I, and now temp will have that particular last node which we have added. Otherwise temp will have the address of that node where I is already present. In either case I will have to append the next list. I will say append next of this temp by Z. Add that node of I and append its next by Z. Follow the same thing other way round. Temp equal to search down H comma Z. If temp is equal to null, then temp equal to append down H comma Z, and then append next temp comma I. Any more? And then repeat from here while as usual get ch equal to y. Return h. We'll read the graph. Exactly the same procedure that we had discussed. Search for the first vertex. If present, append its next. If not present, append it in the down list and then append its next. One simple function, that is to print the graph. I will require H node types temp and A node types T to travel horizontally. I will start with the first down node and I will keep on doing this while temp is not null. I will first of all print the vertex over there as temp arrow VER. So the header list का down जो होगा that will be printed, down list का first vertex. Next time it will be the second vertex, but on the new line. And then I am required to print the next node, so I will say T equal to temp arrow next. And while T is not equal to null, printf %d T arrow VER and T equal to T arrow next. So it will go on horizontally in that list, in the next list. We'll keep on printing all the vertices. Then you will have to print null at the end and go to the next line, and then temp equal to temp arrow down. So after printing one horizontal list, you will go to the down and again print the next list. So on the screen you will have the same picture as we had drawn it earlier. Only thing is those boxes will not be there, but you can see 0, then 1, then whatever, null, then the next node below it. And if you are to really see the procedure as whether it is working properly or not, before asking for any more age, you can always give a call print graph H. So exactly in the same sequence as I was drawing it, V0, V1. So V0 dash V1, V1 dash V0. That type of picture you can see anymore. And you can go on adding. You can see that particular multi-list getting built step by step. Just a call from here to the print graph. You will find that without this part, without this block, it will print only the down list. Print the node, go to the down, print the node, go to the down. So only down list will be printed. And then this is printing only the next list, but for every down node. Any doubt up till now? आपको फ्राइडे को देना है, मैं बैठने अटेंड नहीं करने दूंगा फ्राइडे का लेक्चर. एज अ पेनल्टी यू विल मिस वन लेक्चर. नो CD will be provided for Friday's lecture. On Friday I will be starting with trees, and I suppose that you should not be missing any lecture of trees. It's a huge topic. We'll have nearly 30% weightage in the final theory paper. Okay? So बाकी कुछ भी नहीं, no penalty, no excuses. Printout has to be submitted on the gate and no copy because I will be collecting it. खुद रन करना है, मुझे पता है कि कोड क्या है. ओके, इनपुट अलग अलग हो सकता है, पर्सन टू पर्सन इनपुट कैन नॉट बी द सेम. कहीं ना कुछ तो कुछ गड़बड़ तो होती है. आइडेंटिकल प्रिंटआउट्स नहीं मिलते. In a class of 100 students, I used to make out हर एक का प्रिंट आउट लेके किसका सही है और किसका कॉपी है, मतलब किन का कॉपी है, द ग्रुप. आई जस्ट कीप दोज प्रिंट आउट सेपरेटली. DSF में ऐसे 2-3 बार ही होगा. दिस इज द फर्स्ट टाइम नाउ. 3 या 4 प्रोग्राम्स आपको डायरेक्टली मुझे देने पड़ेंगे फर्स्ट, और उसमें सब कुछ होता है. लाइक दिस प्रोग्राम विल हैव एवरीथिंग दैट वी हैव स्टडीड अप टिल नाउ. Trees is a huge topic. Don't miss any lecture. It will be almost, it will nearly take 1 month when we start with trees. A huge topic. So many applications of it. Right? Okay, now the function BFS. Currently there is a wave like feel good and all, right? So I am making you feel good by asking you to do this assignment. Why? How will you feel good? Because on that day you will feel good because Abhankar is not teaching in your college. You might have saved 3,000 rupees, but then you would be in a miserable situation, because then every week's printout I used to take on every Wednesday. Whatever I teach, that printout has to be submitted on Wednesday by hook or crook. Seniors होंगे सिंहगढ़ में वगैरह तो पूछो. और नहीं दिया तो असाइनमेंट नहीं आएगी टर्म वर्क में. लेट वगैरह का कोई सवाल ही पैदा नहीं होता. कॉपी किया तो भी नहीं होता. copy is not allowed. Maximum 3 identical printouts are acceptable. The 4th one will be discarded. So that is a feel-good factor now for you. You will experience it when I drive you out on that day. But because you have no excuse, everybody has paid the fees. That's it. I am also feeling it. But do it, it is in your interest. At that time, parents used to call me and say that, कि कौन है कौन ये absent? Because the students used to go home. These assignments are pretty simple. I used to carry out the same thing for the 3rd year computer graphics also. And that assignment, if you by chance come back to me for graphics, then you will feel that I go on expanding that assignment like anything. And then students used to say, sir, bus. क्योंकि उनको पता होता था कि once I keep on saying the things, I expect that everything should be implemented in the code. The general program in the computer graphics assignment at that time used to be somewhere around 500 to 600 lines per assignment and 1 week's time. So you have no option. Go home and start typing it. Start executing it. Then and then only it is possible that by that end of that particular week, you can at least come back running to the class and submit it. And you cannot rely. First assignment people depended on others. कि कोई ना कोई करेगा फिर कॉपी करेंगे. But then it is 500 lines program, 8 to 10 pages print out. You can come to the college at 10:30, 11:30 used to be my lecture. Within 1 hour, hardly 4 or 5 people could take the printout. Because it is 10 pages, 12 pages along with the output. So first time they depended, then they said कि जाने दो, कोई करे ना करे, अपना तो कर लेते. But that's the way you should be like. You have entered in the professional course. If you just keep on enjoying Valentine days and all, it's a useless thing. Right? You will get ample time afterwards. It's every hour you should work. Every minute you should be writing the programs. That's the only way to survive. ये बाकी ACD बाकी जो तुम्हारे सब्जेक्ट्स है इलेक्ट्रॉनिक्स के वो एग्जाम के लिए पढ़ के छोड़ देना है, कुछ नहीं है उसका. Programming, you need to have a strong programming base, strong logic base. Okay, because afterwards I will be telling you all the variations into it also, and then those changes you will have to make even in the practicals also. Okay, somebody should help me to write BFS. Same logic, same concept, same algorithm. We will have int types Q of some size, front equal to 0, rear equal to -1. This is first variation. In the practicals, if you write the program in this way and if you complete it in say 1.5 hours or 2 hours, the examiner like me will say that if it is multi-list application, then why you are handling Q by using array? Handle Q also by using linked list. Logic doesn't change, but the functions which we are using, I am using the same functions which I had used for the adjacency matrix, but then those will be of no use. You will have to again declare one more structure, or you can use a node over here and then write the functions for implementing the queue using linked list. And then that should work properly. But when such a variation is given, believe me, you have already cleared the practical exam, because this is a major change in what you have written. If it is 3 hours practical exam, don't leave the practical hall in 2 hours or so time. If you complete it, show it to the examiner. If examiner says okay, ask for the modifications. That's the only way you can score. Even if you don't do those modifications, that doesn't matter. नहीं हुआ आपसे तो भी, but that courage has to be there, and then the examiner will be willing to give you more marks. And then irrespective of who is the examiner and whether he is capable or not, that psychological effect will always be carried out. Okay, उसको पता है नहीं है, उसको भी वो प्रोग्राम लिखना नहीं आता, still he can ask you to write the program. ठीक है, if you can really do it, then because when he says okay you can go, that means you have passed, because you already have the printout and you have shown it. Save that program, open another file, copy that, and then do the modification. So after half an hour or so, if that particular program doesn't run, then you can always have the earlier version. Don't modify the running code. Because then at one time you have passed and then you are likely to fail also. So in this case, when you run the program using array, and if I ask you to modify it for the linked list, save this, open another file, make a copy and proceed. So if by chance that doesn't work, at least this printout will be always there. Follow this thing. And 3 hours is a huge time. If you have really practiced all the programs, 3 घंटे में जो 3 assignments वो देते हैं आपको, cheat system नहीं है तो out of 3 do 1. You can really do all the 3. जो 3 देते हैं, choose one and that is your practical exam. 3 घंटे में वो तीनों हो सकते हैं. और बोलो क्या लिखूं? Yeah, what do we require after this? I might require the starting vertex. Just refer to previous behaviors. We have asked for the start vertex. There is no need of visited array now, because we are already using it in the down list. Okay, and I will have to check whether the vertex is visited, and I will search for that vertex, and that particular node will be returned by search down. So I will require some hnode types temp also. I will ask the user for the start vertex, and I will read it as I. I will read it as I. What was our step? It was add q. It was q comma and rear comma I. This call is just the same. Actually these 3 statements are identical to the previous one. Now you will have to mark ith vertex as visited. That you will have to search. You will have to search for vertex I in the down list, क्योंकि उसमें वो visit करके हमने flag रखा हुआ है. So search in the down list for vertex I. Now you will definitely find it, क्योंकि graph has already been generated. And then you will have to mark temp arrow visit as true. Over there it was visited into bracket square bracket I equal to 1. Okay, and then I will just say while not q empty into bracket rear, I will start with saying temp equal to del q. I equal to del q, because del q will return integer. I equal to del q, q comma and front comma and rear. I will have to print it. Once I print that vertex, then what do? I will have to travel its next list. Over there we used to travel that row, but we used to check whether g of ij is 1. In this case we need not check, because all those vertices are adjacent. So I will have to keep on traveling in the next, checking every vertex whether it is visited or not. If it is not visited, add it to the queue. So I require a node types t also now, because how will I otherwise travel? So I will say t equal to I will have to first search for that node. Temp equal to search down. This was a easier step over there because I was row number. अब हमें पता नहीं है कि वो I vertex है कहाँ पे डाउन लिस्ट में. So you will have to search for that. Search down H comma I. So you will come to that particular header. And now you will have to travel next. So T equal to temp arrow next. And then the part will begin. Because now I am at the next node of it. I will have to check whether it is visited. If it is not visited, then add it. So I will just say temp equal to search down H T comma VR. वो next list का जो vertex है, that should be searched in the down list. If temp arrow visit, if it is equal to 0, then first of all set it as 1 and add that vertex which one? T arrow here. Of course it is same as temp arrow here also. Add that vertex to the queue. And then go to T equal to T arrow next and keep on doing this while T is not equal to null. While T is not equal to null. आप next list में travel करते जाओगे. This loop will simply make you travel in the next list. Every time the vertex that you have, search for its position. Okay, check whether it is visited. If it is not visited, mark it as visited, add it to the queue, go to the next node. Search for in the down list, ये searching for visited है मेरा. Search in the down list, find that node, check whether it is visited. If not visited, add. If visited, go to the next node. When you reach null, जो हमने अभी निकाला था vertex, उसके सभी adjacent को हमने डाल दिया. And then complete that while not queue empty. And then I suppose complete the function also. क्या हुआ भूषण? सी लॉजिकली हम क्या कर रहे हैं, एक वर्टेक्स जो क्यू से निकाला उसका नेक्स्ट चाहिए हमें. सो यू विल हैव टू सर्च फॉर दैट वर्टेक्स. वहां पे रो नंबर डायरेक्टली मिलता था, यहां पे हमें उस नोड तक जाना पड़ेगा. वंस यू गो देयर, तो वो नोड तो हमने ऑलरेडी प्रिंट किया है. गो टू इट्स नेक्स्ट. सो आई एम एट द फर्स्ट नोड इन द नेक्स्ट लिस्ट ऑफ दैट नोड जो अभी प्रिंट किया था. अब हम जहां रो वाइज ट्रैवल कर रहे थे वैसे नेक्स्ट 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 जाना है. हर टाइम नेक्स्ट जाके आपको चेक करना है कि वो विजिट हुआ है कि नहीं. ये सर्च डाउन एंड फिर उसका विजिट ही हमें बताएगा कि विजिटेड है कि नहीं. विजिट नहीं किया है, टेम्प विजिट इज स्टिल 0, मार्क इट एज विजिटेड, एड इट. क्यू में क्या जाता है, वर्टेक्स नंबर. Okay, and the DFS of this change queue to stack. Output of this particular program will not be identical to the output of the previous program, though it is BFS only. Reason is over there when you start with vertex V0 or V1, उसके बाद रो में ट्रैवल करते वक्त all the adjacent vertices they were reached in the ascending manner. पहले V4, V1, फिर V4, फिर V6. अब ऐसा नहीं है. If you see that list, the next list is not sorted. उसमें पहले V6 भी आ सकता है क्योंकि उसने जिस सीक्वेंस में हमें एजेस दिए हैं उस सीक्वेंस में हमने उसे ऐड किया हुआ है. लेकिन मान लो यहाँ पे हमारा एक्चुअली ये टॉपिक खत्म होता है. आई एम जस्ट टेलिंग यू द वेरिएशंस. मान लो कि मैंने कहा कि मुझे आउटपुट पहले जैसा चाहिए, तो yeah, you will have to go for not append but place it, find out its correct position. so that the next list will be ascending manner. So that will add one more function. Even this much modification itself will make you spend another half an hour to complete the assignment. Okay? So should I sort the down list? No. क्योंकि डाउन लिस्ट में 1 by 1 ट्रैवल्सल है ही नहीं. नेक्स्ट लिस्ट हैज टू बी सॉर्टेड. ओके, ये एक वेरिएशन हो गया. सेकेंड वेरिएशन मैंने अपेंड डाउन कहा एंड अपेंड नेक्स्ट कहा. व्हाई अपेंड? क्योंकि अपेंड में मुझे हर बार पूरा लिस्ट ट्रैवल करके जाना पड़ा और फिर मैंने पोजीशन फाइंड करके वहां पे इंसर्ट किया. वैसे है तो वो लिस्ट, उसमें ऑर्डर तो नहीं है जो मैंने अभी सॉल्व किया. उसमें सॉर्टेड किया तो दैट इज ऑल टुगेदर अ डिफरेंट इशू. लेकिन अपेंड क्यों किया? डू आई हैव एनी आंसर? मेरे पास सिर्फ एक आंसर है. क्योंकि मैं अगर ऐड बिगिन से करता था तो एक नोड मैंने ड्रॉ किया, दूसरा उसका एडजेसेंट ड्रॉ किया. ऐड बिगिन करने पर मुझे ये नोड रब करके आगे लेके जाना पड़ता था. सो मुझे पढ़ाने में काफी तकलीफ होती, क्योंकि मुझे बार बार उसे ही रब करके ड्रॉ करना पड़ता था. इसलिए पढ़ाते वक्त इट इज इजियर कि आई गो फॉर अपेंड. इवन डाउन लिस्ट को अपेंड करने की जरूरत नहीं है. हर बार यू आर गोइंग टिल द एंड एंड देन अपेंड एडिंग द नोड. यू कैन ऑलवेज गो फॉर ऐड बिगिन, नेक्स्ट में ही ऐड कर दो ना. ओके, सो जहां मैंने अपेंड डाउन लिखा है एंड अपेंड नेक्स्ट लिखा है, इट कुड बी ऐड बिगिन डाउन, ऐड बिगिन नेक्स्ट, एंड दैट पर्टिकुलर प्रोग्राम विल बी फास्टर देन दिस वन. क्योंकि हर नेक्स्ट लिस्ट का ट्रैवल्सल एंड हर डाउन लिस्ट का ट्रैवल्सल एलिमिनेट हो सकता है, विच इज अगेन अ मॉडिफिकेशन दैट कैन बी आस्क्ड. Okay, so BFS DFS is one of the assignments in our term work if they have not started with graphs, and two more assignments on graphs are Prim's algorithm and Kruskal's, which you have studied in DSGT or DLS, whatever. So those two will